Okay, so here's an example of solving a missing side of a right triangle using Pythagorean theorem. Now, you can only use the theorem a squared plus b squared equals c squared with right triangles. So this little square here in the corner of the triangle means it's a right triangle. Hey, there's 3 prerequisite knowledge skills you want to try to master before you practice these problems in order to feel confident and feel comfortable. You need to understand exponents and what the rules associated with multiplying bases and what you would do with the exponents. You would want to understand what makes up a perfect square and how you simplify a perfect square. And finally, you'd want to understand how to simplify square roots. Mostly perfect squares, but there will be times when you will not have a perfect square and you will simplify and end up with a decimal answer. So those are the 3 prerequisite skills that you would really want to try to master before feeling confident and comfortable with these type of problems. So again, 90-degree angle, we use the a squared plus b squared equals c squared to find one of these missing side values. Now, the left side and the base side of this right triangle are called the legs. The leg. So A represents one leg. And then we have the B value, which also represents another leg. So the value for A is 3. The value for B is 4. And the value for C is unknown. Now, directly across the 90-degree angle, you have the longest length of the sides of this triangle, which is called the hypotenuse. So the value for C will always, always, always be longer than A and longer than B. Now, again, you can only use Pythagorean's theorem with a 90-degree right triangle. Hey, let's go ahead and get started. So step 1 would be to use the formula a squared plus b squared equals c squared. I suggest you write this down so you can clearly see all of your steps. And if you made a mistake, you can find out where and then fix the mistake, learn from it, and do not do that mistake again. So you can see here the value of a is 3. So in the formula where you see a, I'm going to substitute 3. Keep in mind this power of 2 stays the same. Plus, plus, I'll rewrite that. The value of b equals 4, so I'm going to substitute 4 for b. Notice that power of the 2 stays in the same place. I'll rewrite the equal sign, and then the c squared, because I don't know what the value of c is. That's what we're going to be solving. And by the way, in order to get the value of c, we have to free up the term c from this power of 2 by doing the opposite, which is the square root. And that'll come a little bit later towards steps 5 and 6. So again, first step, substitute those values. Step 2, we want to simplify, right? And we're following the order of operations, right? Nothing we can do inside the parentheses. Exponents is the second step in the order of operation. So we simplify. 3 squared means 3 times 3. Plus plus, 4 squared means 4 times 4 equals c squared. Now we're not doing anything with the c squared till later. That'll be one of our last steps. So we're just going to keep rewriting it each step we take. So from step 2 to 3, we're going to simplify what we did in step 2. 3 times 3 is 9. Plus plus, 4 times 4 is 16. Rewrite that equal sign, and then just bring that c squared down. For step 4, we will simplify a little bit further. 9 plus 16 is 25. And equals equals, and bring down that c squared. So here is one of the last steps we want to take, and we want to get rid of that power of the 2 attached to the c. Again, our whole goal is to get that c variable all by itself. So I have to do something to the right side of the equal sign. But what I do to one side of the equal sign, I have to do to the other side as well. So we take the inverse or the opposite operation of a power of 2, and that is to square, we want a radical, put that square root over that c squared value. But again, what you do to the right side, you want to do to the left side of that equal sign. So there's my square root to both sides of the equal sign. So I'll square root that 25. Now, in order to free up any values from a radical, you need a perfect square. Perfect square are two of the exact same terms. You need, in a square root, you need two of the exact same items. In a cubed root, you need three of the exact same items to pull out one value or to simplify one value. In a fourth root, you need four of the same terms. In a fifth root, you need five of the same terms, again, just to pull out one value of the terms. But since these are square roots, we only need two of the exact same items. And when you multiply c times c, you get c squared. So c squared is a perfect square. C times c. Again, refer back to multiplying exponents with the same base. You add, in this case, invisible ones. 1 plus 1 would be 2. So c squared breaks down to c times c. Now the square root of 25 on the other side is also a perfect square. It's 5 times 5. So I have two perfect pairs in a square root to pull out one value, 5. I have two perfect values of c. So I can pull out one value. C is now all by itself. C equals 5. The value of 5. So what does that mean? Let's go ahead and take a look. As we come up here, you can see c equals 5. Now, if you want to check your answer, right, you would want to make sure that both sides of the equal sign are the same. So if I have the value of a, the value of b, and now the value of c, I can substitute those values, simplify, and one side should equal the other side. So let me show you here. My value of a is 3. And don't forget that squared, okay, plus the value of b, and don't forget your square, is equal to, straighten that up, is equal to the value of c squared. So let me substitute those values. I know that the leg of b is 4, and I know the hypotenuse is 5. Now, 3 squared is 3 times 3, which is 9, plus 4 squared is 4 times 4, which is 16, equals, what is 5 times 5 is 25. So can you say 9 plus 16 is 25 equals what I had on the right side, 25? Hey, does 25 equal 25? Is that a true statement? Then yes, you just checked your answer. C has got to be the value of 5. So the hypotenuse is 5, the base leg is 4, and the leg A has a value of 3. I hope this helped you out.